is I want to make sure we go over that 89 and 90 to the extent that you feel comfortable with it. We do indeed have the test tomorrow, so I'm happy to answer any questions. Number 10, I'm happy to work on. I will tell you, you will not see one of that extent, but I will work it just for extra practice. Okay, so that's definitely one we want to clear denominator on. Agree? So the smallest number that 2 goes into and 3 goes into and 6 goes into would be 6. Now, some of you might be like, what about 12? 12 would work as well. It's just you'd have to reduce a little bit more at the end. So I'm going to multiply this by 6 over 1, this by 6 over 1, and this by 6 over 1. So 2 goes into 6 3 times. 3 times w is 3w plus 3 goes into 6 twice. 2 times 1 is 2, is less than. 6 goes in itself, so 5 times 1 is that. So then we get down to that problem. Does that seem okay? All right. So it's just a single inequality. We don't have to split it in anything. So I'm going to subtract 2 from both sides. Those cancel. And then what's the last step?
Divide both sides by 3.
Yeah, good. Divide both sides by 3. So w is less than 1. So that's our inequality. Okay, now I don't know what it asked for. If we wanted to put it on a number line, we could say, well, this is an open dot going this way to negative infinity. So that's our graph. And then the interval notation, we read our graph from left to right. So from negative infinity to 1, soft brackets on both of those. Cool. What else did you see on page 89, 90? Yeah.
You said that we won't see this, right?
Not, I don't think I might have one that you might have one denominator and you just multiply everything by the denominator and get rid of it. I don't think I have one that has multiple denominators. I'm almost positive. If we do, I'll tell you what, just for you, Key, I'll work it out in front of the class. And there'll still be the one kid who misses it, going, dude, it was on the board. I kid you not. It always happens. What other questions? Did you see anything? Yeah, go ahead.
Me?
Yeah.
17. Wait, no, not 17, 15.
15. Okay. Number 15, they give us this inequality. So solve the inequality, graph the solution, give an interval notation. Okay, so this is an and problem because there's 2 of them, and we don't see the word or. So that middle goes with both. So break it into 2 problems. And start solving it. Subtract 12, subtract 12. So I get negative 5 is less than c. I'm going to keep this answer right here, but I'm also going to flip it over for when I graph it. But I boxed in the one answer because I'm going to have to put it back together eventually. Subtract 12, subtract 12. So c is less than 1. Okay, so because this was put together, I want to put those back together. Notice the c is in the right location to put it back together. So my inequality answer is negative 5 is less than c, which is less than 1. Okay, but that's sometimes confusing to look at when you go and graph it. So if you look at a graph, I have a negative 5 here. I have a positive 1 here. Do you agree that's about a good location for those? All right, so c is greater than 5, so it's an open dot on 5 going to the right. And then this we'll do in blue. C is less than 1. Open dot going this way. Is there overlap between my 2? Boy, I think so. This is my overlapped region. So my interval notation is negative 5 to 1. What kind of brackets on these?
Soft. Yeah.
Both soft. They're both open dot. Neither of them have an equal sign. Okay? Yes.
So, if it has a graph, does it matter where you put the numbers?
No, I mean, just make sure you know that a negative number is to the left of a positive number, but I'm not looking for you to like count out little tick marks. Drives me. I mean, I will probably give you like tick marks like the ones given, but if you're handwriting it, you just put two numbers and call it good. Idiot. What else did you see on this assignment that could help you out? Yes.
Again? 12.
Well, all right. Number 12, 5n plus 7 is greater than 4 minus 2 parentheses 6 plus 5n. So it's not an and or an or problem because it's only a single inequality. So we just need to start solving it. So nothing to do on this side. We're going to keep it as is for right now. I need to make sure I distribute negative 2 over. So I get 4 minus 12 minus 10n. Let me pause there. Do you feel comfortable with the math I just did? Cool. These are like terms, so let's combine those together before we start moving things back and forth. 4 subtract 12, I believe, is negative 8. And then we got to start someplace. So I could subtract 5n, I could subtract 7, I could add 8. I think I'll decide. Hi. Okay, cool. I think I'm choosing to start by adding 10n to both sides, but you could have chosen differently. 15n plus 7 is greater than or equal to negative 8. What should I do now?
Minus 7.
Minus 7, good. Those cancel, so I get 15n is greater than or equal to negative 15. Divide by 15. Does the sign flip? No. The 15 I was dividing by is not negative. Doesn't matter if the top was. So that's my inequality. So if you were to put it on a number line, you'd have negative 1. I guess you'd have a solid dot you'd put on it because it was an equal sign, and it's going to shade to the right. So that's going to infinity. So my interval notation is going to be negative 1 to infinity. Infinity always has a soft bracket. What kind of brackets on the negative 1? Hard. Why is that? Equal sign. Good. Here's your answer. Did you go 4 minus 2 on yours?
No, I did 59 plus 7 is greater than or equal to 4 minus 12, and then 4 minus negative 12, and I minus 7 on 7 and negative 12, so I got negative 15 n is greater than or equal to 4 minus 5. And then I did the 4 minus 5 equals negative 1, and then I divided both by 15. And then I got n is greater than or
You made a mistake someplace in there, I think.
Did you say the least amount? Oh, I did minus negative 12 minus 7.
What else? I saw another hand. Savannah, what's yours?
14.
14? Hey! What's up, Cupcake? Not here. I'm sorry, Savannah, you said which one?
14.
14, you got it. It's an OR problem, agree? So it could shade opposite directions, they could overlap each other. So let's solve each of them. So I'm going to subtract 5 as the first move on the first one. Is that 4? Divide by negative 2. Talk to me, friends. What happens when yeah, that sign's got to flip because that was a negative I divided by. So I'm going to get y is less than negative 2. Agree with the work? On the other side, let's see, I'm going to combine my two like terms before I start moving anything. And then what should I do from there? No, I want the y by itself. I don't have any like terms on either side right now. Subtract 4y. Yeah, you want y by itself, so let's start moving the y's around. So 5y minus 4y is 1y. 1y is the same thing as y. So y is greater than 5. Hey friends, do I put ors back together? No. So you want to have your answer like this. If you wanted the inequality, friends, you want to make sure you have the or sign, or the word or. If they wanted it graphed, let's see, I got -2 down here. I have an open dot going this way, so that's pointing to negative infinity. I got a 5 over here, and that's an open dot, and that's going all the way to infinity. Okay, so or problems work that way, where you can shade opposite directions. So my interval notation is going to be negative infinity to -2. You want to include what word? Or 5 to infinity. You don't want to miss one point because you forget to put or. Okay, you want to make sure you get that. Yeehaw. What else, my friends? Take an honest look at it. It's okay. Yep.
Can you do numbers 9?
Snine.
9.
Snine. I'll do snine. Number 9. 4p is less than 6p plus 12. It's not an and or an or problem because we only have one inequality. So I'm going to subtract 6p from both sides. Those cancel. So 4p minus 6p, I believe, is -2p. Divide both sides by -2. We have a negative. So what happens to our inequality sign? It flips. Thank you. 12 over -2, I think, is -6. Okay, so that's my inequality. I put it on a number line. I got -6. I have an open dot, and it's going to the right, so that's going to infinity. My interval notation is going from -6 to infinity. I always have a soft bracket on the infinity. What kind of bracket I have on -6? Soft. There's no equal sign, so that's my interval notation. What else do you see? Yes, I'm sorry.
You do 13.
13. Number 13, 3 minus 2, x plus 9 is greater than 15. Okay, this is one you want to be careful. That -2 needs to be distributed. Do not go 3 minus 2. You're not doing order of operations if you go 3 minus 2. So, I'm going to get 3. -2 times x is -2x. -2 times 9 is -18. It's greater than 15. Do you agree with the math I did so far? Notice how the signs changed. Okay, don't make that error. Those are like terms, so let's combine those together. So that's what, -15? And then we want to get x by itself, so I'm going to add 15 to both sides. Those cancel, so -2x is greater than 15 plus 15, I think, is 30. Divide each side by -2. So I'm dividing by a negative. So what happens to the inequality sign, my friends? Flips it. All right, so I'm going to get x is less than 30 over -2 is -15. So that's my inequality. Put it on number line. So -15, open dot going left, so that's going to -infinity. My interval notation is -infinity to negative 15, soft bracket on the negative 15. Yeah, buddy.
Never mind it.
You got it? Cool. Yes.
Okay, so if we write it down negative 15, negative 8, is that still works?
That's 1 point off. You want to do your interval notation left to right like you would read a book. Unless you read one of those books in a mirror. Left to right. You want the furthest left to the furthest right in that order. So if you flipped it over, if you had it negative 15 to negative 8 or negative infinity, that's 1 point off. So just make sure you have it going correct, left to right. Anything else you want to see? Yes, back to our 16. Hey, what kind of problem is number 16?
Or.
Yeah, how do you know? Dude, the word or is there. Okay, so I don't have to even work these out because it's already done for us. I'm just going to put it on a number line. I get a 3 here. I get a 5 here. So this would be an open dot at 3 going forever to this way, to infinity. Bless you. This would be an open dot going this way. Or problems can overlap, but they don't have to. It's just you want to talk about the direction you're going. So no matter where I go along this number line, something will work on one or the other. So my, oops, I don't want highlighter. So my interval notation will be negative to positive infinity because every number in the world will work. It'll satisfy one or the other. Sometimes it might satisfy both, and that's okay. So remember the or statements are like you had 2 different ways of doing something. You could punch in a key code or you could use a key. So they'll both get you in. Yes, ma'am?
So if it's overlapping, or would it always be maybe
Yeah, there are some, let's see, let's say this is not one of them on our paper, but let's say we had an or problem that we had graphed it, and this one went like this, and this one went like this. They both went the same way. So this is some number. So it would be soft bracket number to infinity. I don't think we have any that are going the same direction, but I mean, theoretically that could happen, but I don't think on the test I'm going to have one like that. Mainly the ors on the test, you're going to have, if it was 2 of them, you'd probably get, something like a solid dot going this way to negative infinity, open dot going this way to infinity. So let's call this point x, x and y representing whatever numbers we want. So negative infinity to x square bracket, or soft bracket y to infinity. I won't have x and y's on there. I just wanted to have arbitrary values. And I bet you would also have an or problem that would look like the one we just did. So let's say we have an x value going this way, and then we have a y value, and again x and y representing whatever, going this way. So this one would be a negative to positive infinity because it was an or problem. Okay? If this top one, if this was an and problem, there's no overlap, so it has to be no solution. If this bottom one was an and problem, you're bounding it between x and y for your interval notation. It's not, negative to positive infinity. So just be very aware. So any other questions you want me to do, or we can talk about review? Yeah. Go ahead. 19. So number 19 is this. It is an and problem because the word or is not there, so we're looking for overlap. Agree? All right, so I want the middle part to go with both problems. I'm going to write out both problems. And again, the middle goes with both. So on this one, I'm going to distribute 2 over the parentheses. And solve that. Add 16, add 16. Let's see. That's going to give me 10 less than 2y. Divide by 2, divide by 2. 5 is less than y. So let's keep this one like that. But I know that I can flip it over to look on the number line. And then this one, I'm going to distribute 2y over that, or 2 over the parentheses. Those cancel. So 28, divide by 2, divide by 2. Y is less than 14. Okay, so because this was originally put together, you want to put those 2 together, which is going to give me 5 is less than y, which is less than 14. That's my inequality. On a number line, I'd have a 5 here. I'd have a 14 here. So I want values greater than 5. That way. I want values less than 14 going this way. We definitely have some overlap right here. Okay, the overlap is what we want. That's what the and is. So my overlap will go from 5 to 14, both soft brackets. That's my interval notation. Excuse me a minute. I need to go grab my charger for my computer. It's going to die. It's still alive, barely kicking. Uh-oh, not seeing the cord. There it goes. Yay. Anything else? Yes.
So for those kind of and problems, do we have to have the inequality be like the 5 left and y is less than 14, or can we just have the 2?
You know what? Why don't I grab the test and I'll take a look and make sure we're good. Did anybody want a copy of this to take home? Okay. Yeah. All right, so, and you can write this down as notes on wherever. On problems 1 through 5, problems 1 through 5 are this type of problem, where you might have something like this. Or you might have something like this. Or you might have something like this. And then you might have something like this. Okay. What they would want on each of these problems is they want the interval notation to be written. Okay? So, for this first one, we'll do in green. What should the interval notation of that be? 8 to what?
Infinity.
Infinity. And a what?
Hard bracket.
Hard bracket on the 8 and a soft bracket on the infinity. What about this one? How would you do this one? Interval notation. Negative infinity to negative 3. What kind of brackets? Soft on everything. What about on this one? Any ideas? Negative 10 to negative 1. And what? Hard bracket on both. Excellent job. Hard bracket because they were both solid dots. If one was an open dot, it would have a soft bracket on that one. And then, let's go with this lime green. I don't know how good that'll show up. What's that? Interval notation. There are two things, yes. Negative infinity, negative 10. What kind of brackets? Both soft. All right. Now, what kind of problem would this have been? And or. What kind? Or. What do you have to have with or? You want to make sure you have that. So if you had that written down as some sort of study notes, or you looked at 25 minutes into the lesson on the video that I'll save, that will be that kind of problem. Any questions on that? So you'll have 5 problems in that kind of fashion. Yeah.
How would we know if it's that one's an and or?
Well, the top one is an and because that's overlap. Okay. Now it's very possible this would have been an or problem, but if it was an or problem, the lines would have kept going both directions. You know this is an or problem because we have this side or this side. So that's why you know there's an or situation.
Oh.
Okay. But 11.
Attention faculty, staff, and students. Sorry for this brief interruption. Students, tomorrow please bring your device that the school checked out to you so you can turn it on in advisories for updates. That will help with future assessments. So again, just bring your device tomorrow. All you're going to do is turn it on in advisory so it can update if it hasn't already done so. Again, sorry for the interruption.
Okay. So are we good? So these are only 4 examples, but there'll be 5 problems similar to this. Is that okay?
How much problems are in the test?
20. So that's 1/4 of it. Cool? Is that all right? All right. The next 3 problems, so 6, 7, and 8, will be something like this. So you might have one that is negative infinity to 3, hard bracket, or let's go 9 to infinity. And we want to graph that. So how are we going to graph that on one number line? Yeah.
You do the 3 and the 9.
Okay.
And then circle or color in the 3.
3 is a solid dot. Cool.
Going to the left.
Going to the left. Very good.
And then 9 is an open dot and going to the right.
Going to the right. That's exactly right. Good job. Okay, things I'm looking at on that problem. I'm looking for an open dot versus a closed dot. I'm looking to see if you shaded it the right way. How would you do, say, this problem? Yeah.
The -2 and the 5.
Okay.
And then hard or solid dot on the 5.
Solid on the 5.
And open on the 2.
Very good.
And then you just
Shade in between them. That's it. So 8 out of 20 of the problems is now done. Am I right? The next problems that you'll see So it's basically problems 9 through 18 will be like, you might have something like this. 2 minus 3x plus 4 is less than 5. And they will want you to graph it and do the interval notation. Okay, so how do I solve this type of problem? Yeah,
You do 3 times x.
close.
2 minus 3?
No. The 3 is right, but what about the 3?
Oh, it's 3x?
No.
You add 3?
Nope. You multiply by? Good. You multiply negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. Make sure you distribute the negative over the parentheses. Here are some like terms. And I made this up, so it might not turn out to be a real comfortable answer.
Wouldn't it be negative 10?
Ooh. Yes. Yeah, that's a 10, that's a 10, that's a 10. Thank you. Okay, so those now cancel. So negative 3x is less than 15. And it actually, by the luck of Stirrup, and with some keen eyes, hey, I divided by a negative. What happens to our sign? Flips. X is greater than negative 5. So if I were to graph it, I have negative 5, open dot, going right. So that's the graph. The interval notation would be soft bracket negative 5 to infinity. So I'd be looking for these two parts, and of course, that you have some sort of work. Okay? I mean, show as much work as you need to say. It's really hard for me to decipher how in the world did you come up with this answer when nothing else is shown. I did it in my head. Really? I've graded a lot of your papers. I did it in my head. Doesn't really hold true all the time. I mean, if it's 5 plus 6, yeah, you can do it in your head. That's an awful lot to do in your head. Okay, now not every problem is going to be like that, but it's that type of problem where you'll have a single inequality. Sometimes you might have the two inequalities with the ands and the ors. Okay, so those all take place. And we've just worked a bunch of those types of problems, especially on the worksheet. So it looks like 9 through 12 is only one inequality sign. Bless you. Okay, if it's one inequality sign, that means you have the dot either solid or open, shade right or left. And then 13 through 18 have, they are compound inequalities, meaning you might have the word or in there, you might put the word and in there. Realize that an and problem also might look like this. Okay, that's also an and problem. Okay, and problems, be sure to put back together. Okay, and then the last two problems on the test, 19 or 20, is find the error. Okay, so you might have a problem like this. Let's say a problem like this is given to you on the test. And let's say they haven't worked out, and they haven't worked out like this. Where did the error take place? What do you think? Go ahead.
They should add instead of subtract.
Where?
Negative 5x minus 20, or is it plus?
I think this is the error.
Is it?
Yeah, if I had distributed that over, that should have been a positive 20. So then what you're going to want to do is, here's the error right here. So this is what it should have been. So then you work it out. So it says, each problem has an error, circle the error and write out the correct solution. So then you get to this and you're done. So circle the error. Here's my error right there. Rework it, give me the correct answer. It doesn't say to put it, it just says to do the solution. So it's like that. It does not say put it in interval notation. So the last two problems are that kind of thing where don't look at it and say there's no error. There's an error that's made. The easiest way to do these types of problems is it's really hard to decipher. Sometimes when you're looking at work, your brain's going to fidget around with it. So work the problem originally. Take a look at your answer. Does your answer match the answer on the page? If not, then find where they made the error. Okay. If you did match, you made the same error that we made. Okay. So if you gave this answer as -2 to infinity, you could also have that if you did the interval notation. I don't know if it's 100%. If you gave me this answer versus this answer, I'm going to call it good on both. Okay? So my friends, I strongly encourage you to go back over, take a look at 89 and 90. I have a lot of the problems that are worked out as notes, or the video is there for you to take a look at. And that's all I have for you.